Good morning, class. So we have just discussed the scientific method, and one of the essential steps in it is the experimentation. Let's perform a simple experiment. Get a rubber band or any elastic string. I want you to pull one end of the rubber band as seen in the figure. Be careful that it won't break. Then release the band. Take note of the distance traveled by the band, and using the same rubber band, try to pull the one end a bit farther and see how far it traveled. Which has a greater distance traveled, the first or second release? What could be the cause of the difference? We will go back to this later. Now let's look at another experiment. Kittiwake is a kind of gull that nests high in the cliffs. It is usually found in temperate regions like Alaska. The biologists inferred that the kittiwakes would have more energy if they were given extra feedings while nesting. The biologist's hypothesis was that the kittiwakes would use the extra energy to lay more eggs and raise more chicks. Biologists found nesting pairs of kittiwakes that were similar in mass, age, size, and all other features. They set up a control group and an experimental group. A control group in an experiment is a group used for comparison without any treatment or change applied. In this experiment, the kittiwakes not given the supplemental feedings made up the control group. The experimental group is the group exposed to the factor being tested. The group of kittiwakes getting the supplemental feedings made up the experimental group. When scientists design a controlled experiment, preferably only one factor can change at a time. It is called the independent variable. Because it is the tested factor, it might affect the outcome of the experiment. In the kittiwakes experiment, the supplemental feeding was the independent variable. During an experiment, scientists measure a second factor. This factor is the dependent variable. It results from or depends on the changes to the independent variable. The change in the kittiwake's energy levels as measured in reproductive output was the dependent variable. A constant is a factor that remains fixed during an experiment. In this case, the kittiwakes have similar mass, age, and size. Simply, the independent variable is the cause factor that is being tested or manipulated. It also affects other variables, and it is often abbreviated as IV. While the dependent variable is the effect or the factors you observe. It is the response to the manipulated or independent variable, and it is often abbreviated as DV. The independent and dependent variables can be clearly seen throughout the different steps of the scientific method. Let us see using our first experiment. For the problem, our question can be stated as, does the blank affect the blank? The first blank refers to the variable that we change, the independent variable. The second blank refers to the variable that we measured, the dependent variable. Now let us complete the question. Does the distance a rubber band is pulled back affect the distance a rubber band can travel? One form of stating the hypothesis is to use the if and then statement like this. If the blank is blank, then the blank will blank. Again, the independent variable comes before the dependent variable. However, make sure that the effect, increase or decrease that you choose is logical for the situation. Let us complete the hypothesis. If the distance a rubber band is pulled back is increased, then the distance the rubber band can travel will also increase. In presenting the data, the independent and dependent variables are also seen. In this table, the independent variable is at the first column, while the dependent variable is at the other columns. In a graph as well, the independent variable is placed in the x-axis, while the dependent variable is in the y-axis. Since we mentioned graphs, let us review some common interpretations of the graphs. If you see a line like this, what could you say about the relationship between the independent and dependent variable? As you can see, as you increase the value of the independent variable, the value of the dependent variable also increases. Thus, we call this relationship as directly proportional. How about this? As you increase the value of the independent variable, the value of the dependent variable decreases. Thus, we call this relationship as inversely proportional. Take note, there is no such thing as indirectly proportional. Finally, as you increase the value of the independent variable, the value of the dependent variable remains the same or constant. What can you conclude from this? Either the independent variable has no effect on the dependent variable, or its effect is to maintain its value all throughout. Please watch this YouTube link for further examples on independent and dependent variables.